Welcome to this video. So we start in this module learning about integrating data from other sources than files and relational databases. So far we've been able to read data from files including CSV file and Excel spreadsheets, as well as interacting with relational databases and grabbing data by issuing SQL queries. Of course, data comes from other sources in other different formats. So it's important to learn about different sources, especially sources that are becoming more common today. So today many data providers are providing data over the internet. And many of these providers utilize data formats including XML, JSON, and HTML, data format that become popular with internet websites and internet platforms, as well as utilizing internet protocols for delivering this data. So there are really two separate topics that we want to talk about today. We want to talk about the HTTP protocol, which is the protocol used to communicate in between clients and server over the internet. And by using this protocol, we can request data, and this data can come in multiple formats. And we will be talking about a couple of these formats, including JSON, today XML, in the next time, and also HTML. So let's start by talking about HTTP. So we have to differentiate between the data format itself and the way the data is delivered. The way the data is delivered is called a protocol. So when the data sits on the local machine, on the hard drive, the data is usually delivered using what we call the file system. So when you read a file on your drive, the operating system transfers the request through the file system module, and you get the data delivered through that submodule in the operating system. Of course, when the data comes from outside sources, there are other protocols. For instance, when we use a relational database, each database vendor uses its own protocol to delivering the data. Over the internet, data is usually delivered using the HTTP protocol. So HTTP stands for the Hypertext Transfer Protocol. The architecture of the internet is called the client-server architecture. There is separation between two types of machines, the client and the server, and those clients and the servers communicate using the HTTP protocol. The HTTP protocol communication is a request-reply structure. The client requests a resource, and the server reply providing this resource if available or providing other different directions or information. So let's take a look at the structure of the HTTP protocol. You can read the Wikipedia page. It contains many information about the topic. What's of interest to us is that each resource on the internet, for instance, including this web page on Wikipedia, has what we call a URL, a Unified Resource Indicator, or URI. And you can access this resource by really providing the URL or URI of the resource. That resource locator or your resource indicator or identifier actually has the following structure. The protocol itself, which is for the purpose of our discussion, will be HTTP or HTTPS, which is the encrypted flavor of HTTP. Then user information, which will not be available in most situations. The host, the port, the path to the resource, and a subquery and fragment if possible. So everything you access through the internet, a web page, a picture, a multimedia, has a unified resource locator. Like for instance, if you take a look at this picture here, if you right click and copy link, basically the link provides the locator of the picture. If you paste it to your browser, that's basically how you access this picture over the internet. If you hit enter, you will load the picture here, right? So when the client and the server communicate, there are different kind of requests that the client can make to the server. So the most important request for the purpose of our discussion, which is getting data, is called the GET request, or the GET method. And this basically requests a resource from the server to be sent to the client. Now this is one of the requests, but there are many more requests, including posting, which is to either to modify an existing resource, putting, which is to put a new resource on the server, deleting, which is to delete a resource, as well as other requests that the client can make. Now, again, we will be mostly interested on the GET request, but you have to keep in mind that these requests are becoming very popular to provide services over the internet. So many often, and this is a topic we will talk about today, data providers, platforms provide APIs, application programming interface, so that developers and programmers can interact with the service providers using these requests. So let's take a look at some of the examples here and talk about using the requests package in Python, which is the package that allows us to make HTTP requests to web servers. And along the way, we'll talk about the different data formats that are provided to us, and today we'll talk about the JSON data format. All right, so first I imported the package requests, and then what I'm doing here, I'm requesting a resource from the server. So the request package provides different functions, and those functions map to the different HTTP requests, such as put and get, get for a purpose of our discussion, but obviously you've got requests to match the other functions, the other methods of the HTTP protocol. For the purpose of this exercise, let's say we are interested in getting this resource. Now this resource, if you copy and paste it into the browser, you will see that this is basically a personal web page, my personal web page. And when you grab the resource, the server will deliver the content of this web page to the client. Now let's first do the request, and it will take a while because this request is going through the internet. And then we get a response object. Now the response object contains different kind of information, and we can see that if we invoke code completion by hitting tab after the dot, there are different things that the response object provide to us. We'll be interested here about the status code. Status 200 range means the request is successful. So we need to check whether the request is successful. The request may not be successful if the resource does not exist, for example. Let's say I have a typo in the URL. If the URL doesn't exist, I will get 404. Anything with 400, it means it's not successful. 404 probably means resource doesn't exist. Things of that nature. We can take a look at the headers of the response object. This contains some meta information, including date and time, the server, which is an Apache server here, and other kind of meta information for us. The most important one is the content type. So the content type is important because resources can come in different types, right? Not only we have web pages, but we also have binary resources such as pictures and other kinds of multimedia. We also have resources that are not necessarily web pages, that contains data resources, as we will see. In this example, we've got a content type which is text/HTML. That means that this web page, this resource, is basically a web page encoded using a language called HTML. So HTML stands for the Hypertext Markup Language. So it's a language that allows us to develop web pages. It's a markup language very much like Markdown. It basically allows us to provide some extra markup on top of the content of the page. If you've done any kind of web development before, you probably learned about HTML. That's basically the source code of what you see here. When we look at this browser, we see a nicely formatted web page. But this web page is written in a kind of a markup language. Underneath the hood, you can take a look at the source by right-clicking and going to probably inspect element or maybe view page source. Somewhere it should be hidden. So we can probably see here show page source. If we click on show page source, that's the source code of the page in HTML. Of course, the browser will read the HTML and it will render the page for us to see. Going back to Python, this is basically what we get. We don't get a nice page here because that's the text of the source code in HTML. Now what I have done here, I imported a function called display and a function called HTML. Those two functions can be used to render the page within your notebook. We don't need to do it in most cases, but they're useful if we're trying to integrate external content in our notebooks. If I do display HTML response to text, we can see a rendering of the page here within our notebook. Now, it doesn't show the pictures here for a reason we'll talk about. It only shows the text included in that resource, because to show pictures you need to request all of the other resources that the text, the HTML, links to, which is not done automatically here by Python. Okay, so that's how we request resources over the internet. And this applies to anything you do in your browser. Anything you type in the browser address is basically a resource locator. You can issue a GET request and get it delivered to you in Python using the requests package. So let's do this example. Let's take a look at this picture, for instance. I'm going to copy image address. If I copy the image address, that's basically the resource locator for this image. If I go to my code here, and let's do image is equal to requests.get this resource, will take a while, and let's check the status code here. That's 200. If I check image.headers here, it will tell me that the content type is image JPEG, right? So it's not text, it's binary actually, so we need to render it appropriately if you want to do any data processing. Right. Here's another example. This is Google search. If you search on Google, you can access the resource search, and optionally you can provide a query. So if you copy and paste this URL in your browser, you will see that you're basically doing a web search using Google here. What you see in the browser here can be requested here automatically. We can do display if you wish. That's basically the result of the request, right? It's the HTML content of that response object. The function get has optional parameters, so it's possible to provide the resource and an optional parameters to specify the parameters of the resource. So instead of typing everything in one resource locator, we can provide the basic resource, and then the parameter for Google is Q. The value is Terry College of Business. So this is useful because I don't need to, type a big URL. I can split it to the resource and what I'm searching for. So let's say, for instance, I'm searching for HTTP. So now we move on to talk about JSON. So JSON stands for the JavaScript Object Notation. Now, on the internet, JavaScript is the most common, most popular language. It comes built in all web browsers, and it allows web developers to do things on their web pages to make it more interactive. If you've done web development, you've probably learned and used JavaScript before. If not, you don't need to know about JavaScript. But what you need to know is that JavaScript has a special representation to represent objects. This representation is called JSON. Let's take a look at this example here. Again, this is the Wikipedia page about JSON. This example represents an object about a person. First name is John, last name is Smith, is alive is true, age is 27, address, phone numbers, children, spouse, and so on and so forth. Now you can see that this notation looks very similar to a dictionary in Python. The curly brackets, keys associated to values. There is a key which is associated to another object, another dictionary. The address is a composite attribute. It has a street address, city, state, postal code. Phone numbers, you can see it's associated to a list of things with a square bracket, and each one of these things is on its own is a composite object. So the home, the number is the following, the office, the number is the following. Children, it's an empty list. Spouse, there is no spouse. So it's very much like a Python dictionary, which is composed of keys and values, and the values can be just single values or for other dictionaries and lists. But I want to note here that it's not a Python dictionary. There are some differences, and we will take a look at. Now, before we move on to Python, I'm going just to copy and paste this thing here, and I'm going to access this in copy, and go to the notebook, and I'm going to paste this thing here. So let's call this one person. And I'm going to paste it, since this is a multi-line thing, I'm going to paste it within triple quotes here. Notice that I did not paste it as an object here. Again, you may think that this is a valid Python code, but it's not. Well, why? There are several differences. One of them is, for instance, you can see here, true and false in JavaScript are true with a lowercase true, and false with a lowercase false. So if I try to paste this one here, I will get an error because there's nothing called true here. Okay, I can fix it. I can make it bigger T here. Would that work? Well, not quite, because if you can look here, null is not defined. Null in Python is not null, is none. I can fix that. Well, once it's fixed, you can see that we have a dictionary. So let's call this one PD for person dictionary. And now I have myself a dictionary that I can access. So I can do PD first name is John. Okay, PD, let's get, for instance, phone numbers. That's a list of phone numbers, right? And then I can access the first phone number because it's a list. And then I can access number because it's a dictionary, right? So once it's recognized as valid Python dictionary, we can process it as a Python dictionary. But what you note from this exercise is that it's not as straightforward. In this example, I had to fix two things. The true to be true in Python and the null to be none in Python. There are other differences. So we'll not be concerned about all the differences in between the JSON and Python. We have a library called JSON, a package called JSON that does the transformation for us. So let's take a look at this example here. Well, let's look at the person example. Of course, I imported the package JSON in the beginning of this notebook, so you can see that I have imported JSON. And JSON has two useful functions. One of them is to convert a Python object to a JSON string. And the other one is to read a JSON string and convert it to a Python object. So the one to read a JSON string and convert it to a Python object is called read_s for read string. There is another function called read, which will take like an object, a resource, and convert it to a string and a Python object. But here we have it as a string. So read will basically, it's actually not read, it's load string rather than read, excuse me. So this basically will take the string that contains the JSON document and will convert it to a Python object. So in this case, I can take my person string, because person is a string, right? Person, that's the thing. Type person is a string. JSON.load as person, that will give me the dictionary, and that will do all the necessary conversion for me, including converting true to true and null to null. So let's call this one PD2. And that's basically what I have done manually. So let's test that PD2 is equal to PD, and that will be true. Okay. So this is the function that we will be using the most, because we will be reading data from external resources from the internet, and then we will be converting the JSON resources to Python objects to be further processed. Let's take a look at the opposite conversion, which is useful if we want to do the opposite, if you want to convert our Python objects to JSON objects, which is useful if we're operating the other way around. Say we're sending a request or we're putting a resource on a server, we need to do the opposite conversion. The function here is called dump, or dump_s for dump string, which basically will take a string, we'll take a Python object and create a JSON string. So if I dump PD or PD2, I'm basically going to get a Java string object notation or JSON string. And you can see that the conversion here has been the opposite. The true with capital T is now true in JavaScript, the none is null, and so on and so forth. This is another example. This is a dictionary in Python. I converted it to a JSON string, and then I'm going backward, converting it back to another Python object. Obviously, it's equal to the first one. Okay, so now we know how to read JSON objects and convert them to Python objects. Where do we get these JSON objects? Well, they exist on the internet, and they are provided by multiple data providers, multiple platforms, multiple websites provides ways for us to interact with the website, with the platform, using an API, an application program interface. All popular websites have APIs. Your favorite social network has an API. Many data providers have APIs, provide APIs, and we will be seeing a couple of these APIs in these exercises. Now, I just want to point your attention that some of those web providers have a required authentication. So there will be a step needed to get an authentication key or a token or a username and password and authenticate before being able to get data. And of course, they do so because they don't want people to abuse their services. So in these examples, I specifically chose examples that do not require authentication, so we don't go through this extra step. Now that said, authentication is not very difficult. You just need to look at the documentation and make sure you follow the steps. All right, so in this example, I'm going to look at GitHub. So the code of this course is provided on a GitHub repo. GitHub is a website. If I go to my personal page on GitHub, that's my personal page, right? And again, this is provided in HTML. It's provided for human consumption. I can read it, scroll it. It's visually presented for me to use. Of course, I can grab the HTML, but then I need to really reverse engineer the HTML if I want to get the source data. Let's say I want to get a list of my repositories, for instance, or I want to get a list of my activity. I can reverse engineer the HTML, which is something that we may need to do, unfortunately, if the data provider GitHub doesn't provide an API. We will be doing this exercise in 2 sessions when we talk about HTML. Fortunately, GitHub and many other data providers, websites, and web platforms provide APIs. If I go to my website, I'll go to my GitHub site, but I use the URL api.github rather than github.com, this api.github.com is basically providing the same kind of underlying data in a machine-readable format, which is in this case a JSON object. So that's basically the basic data used to render my personal web page provided for me here in a very useful format for machine consumption, which is JSON. This means if I'm interested in doing any computational statistical data analytics activity over GitHub, it's much easier to use api.github.com because this basically gives me the data in machine readable format. Okay. Of course, I can check the documentation of the API. This is something we can all do. If you go to GitHub API, it will give you detailed documentation about what kind of resources, what kind of data is available, and what different kind of queries that we can do. However, I want to point your attention to this acronym called REST. So REST is basically a way to provide APIs over the HTTP, over the internet. A RESTful API allows us to interact with a data provider using the HTTP request, get, post, put, delete, and so on and so forth. Once again, this is becoming very, very popular, and many data providers, many websites, many data vendors provide RESTful APIs for developers and users to use. So what we will be learning to interact with GitHub is the same that has the same structure, for instance, to read from Twitter. If you Google Twitter REST API, that's the basic the API reference index here. It also uses the same RESTful architecture. You can get data from Twitter by using HTTP requests such as get, post, put, delete, and so on and so forth. The same goes for Facebook. The same goes for many data providers, as we will see. In all of these instances, you will need to read the documentation to know what you're doing. We will be doing just 2 simple exercises here to get data from GitHub, and in the workout and the warm-up exercises, we'll do more advanced examples. All right, so let's try to answer this question. How many followers does the user Hanisaf have? Well, this information is provided to us. If you go to my website, it's basically showing the followers. I have 3 followers here, right? It's also provided in the JSON format. If I go to API, github.com users Hanisaf, it will basically says the number of followers here, right? So to answer this question in Python, first I need to request the resource. And the resource has the following format: https api.github.com/user/Hanisaf. And again, this has to do with the API itself. I needed to read the documentation to know that to get a user profile, I need to go to /users/username. Okay, so again, if I go back to the GitHub thing, I need to read the documentation here to see, to understand what I'm doing here and what kind of resources exist. So for instance, here I needed to go to probably project users to get a single user. And this basically telling you that, well, the structure of the URL is /users/username. So api.github.com/user/the username, which is the one in my case, it's HaniSaf. Okay. Obviously, if I was interested in another user, for instance, let's look at user Octocat here. I can change HaniSaf to be Octocat, and I'm getting the data about Octocat here rather than HaniSaf. Okay, let's answer the question here. How many followers does this person have? Now notice that I have gotten the text of this response and converted it to JSON. So data here is a Python dictionary. And what I need to do is to grab the followers key, the value associated with followers, so data followers, and that basically will give me the number of followers. Let's take a look at another example. Let's take a look at the World Bank Open Data. So the World Bank provides its rich number of different data sources and provides an API to access this data. Most of this data is kind of demographics, survey data about different countries, but it's a rich data set which is very useful for any aggregate kind of market research, country demographics, and so on and so forth. Obviously, there is a documentation, a detailed documentation about the API. What we're doing here, we're interested in getting the national debt in one country, which is the USA. So for that purpose, I need to know the country, and I need also to know the indicator. So the URL is the following, is the API worldbank.org v2 and then /country / the name of the country / indicator / the name of the indicator, and then format is JSON, because as we will see, World Bank provides access to this data in multiple formats. So again, this is something you need either to be given, such as in this problem, or something you need to do a research on your own to figure out the structure of the API and what kind of resources it provides and what's the syntax, the query, the URL of different queries it provides. All right, so let's take a look at this URL here. And what I'm going to do, I'm just going to copy and paste it in the browser here. If I copy and paste it here, you can see it's basically giving me the data in JSON format. Okay. So I'm going to do the same here. I'm going to issue a GET request and store the result in a response object. And what I'm going to do here is to look at the response, the status code, and it's 200. Okay, so response.text is basically the content of the resource. That's the JSON thing. And of course, I can do JSON.readS to convert this to a Python object. Again, it's load_s rather than read_s, and that's the dictionary. The response object has a shortcut. It actually provides a function called JSON, which will convert the text to a JSON object. So it's a handy shortcut. If you know for sure you have a JSON text, you can call the function .json, and it will convert it to a Python object here. So what did we get? We get an object called data, and if I type it in, I will see the content of the object here. What do I have? It looks like I have a list here. What is this list? And again, this is something you can do by inspection, or even better, you can know by reading the documentation of the API. I have read the documentation of the API, and this list has two things. It has some metadata and the data itself. So the metadata is the first element, and you can see it's a dictionary. It's basically saying, well, I have 2 pages. Each page contains up to 50 data points, and in total I have 60 data points. So actually we have 60 data points and we only got 50 here. And this data was last updated in February. I'm not sure about the source ID here. The next item in the list is another list which contains the data points. Each data point itself is a dictionary. So this is telling me that the first data point is an indicator. Of course, that's the indicator I provided, which is the central government debt as a percentage of the GDP. Country is US, United States, country code, date, value. Some values are missing, as you can see here. So we can see that 2019, the value was not provided. 2018 not provided, 2017 not provided, 2016 it's provided at 99.017, so on and so forth. Okay, so that's the structure of the data. What do we do with it? We need to convert it to a more useful data format than a list, and we will be going to convert it to a pandas data frame. So first, what I'm going to do, I'm going to look at data 1, which is my list here. It has 50 data points, and I'm going to convert it to a data frame, pd.dataframe data 1, and pandas is going to convert it to a data frame by looking at each key in the dictionary in the list and convert it to a column. So what you can see here, let's read data again. pd.dataframe. We have to import pandas. Remember that PD was the person dictionary, so that overrode that's the person dictionary, overrode the previous import statement. Okay, so that's the data frame, and you can see here that some of the columns have singular values because they're not dictionaries in the list, but some of them have the dictionary value as the value because each one of the country has the ID and the value. And the indicator itself has the indicator ID and the value of the indicator. And there is also the value itself. Now, what's interesting for us here is the value itself. So that's basically the value of value, that's a series. And we can see here that the national debt has been steadily increasing since the data was originally collected in the 1990. Obviously, we can do a better job cleaning the data and making it a more useful data frame. But for the purpose of this exercise, we are interested just in the value itself. So we can grab the value, we can set the index to be date, and grab the value column, which will give us this series. All right, so that concludes the presentation of the concept, the JSON concept. What I'm going to talk about is kind of an optional material. We can see when we use JSON that we're getting a large amount of data, and then we need to sniff through the data ourselves. For instance, in this case, we've got a lot of metadata, a lot of things we don't really care about, so we need to do some data formatting. You can also see here that we got 2 pages of data, right? If I want to continue reading this data, I need to go to the first page to grab the 10 data points. Which means it's kind of like scrolling through a table online. You need to issue multiple requests until all of the pages are done. And that's an issue generally with JSON APIs, that because of the API, each resource is determined by a single resource locator, the data provider doesn't have many options, so they basically pick up the defaults, and it's on you to kind of sniff through the data, filter it out, grab more data, and integrate it. That kind of become a limitation, especially because of the large amount of data provided online. It also kind of becomes very inefficient if you're grabbing a large number of data just to clean it up and select, for instance, one field or one column, something of that nature. So a GraphQL is basically a way to query data through over APIs. So you can think about this as SQL for JSON and RESTful APIs. Now, GraphQL is a recent technology. It's been developed by Facebook and then made open to other developers to benefit from. There are other competing technologies, including SparkQL and including Neo4j, for instance. They provide ways to access and query data over the internet. So this is kind of an area of active development. And not all RESTful APIs, not all data providers, platforms provide GraphQL or SparkQL. But when they do, it's possible to do some more interesting and more focused queries. For instance, in the GitHub example, let's take a look at this example here. We can check the API. Let's answer the question, how many followers does this user have? We can take a look at the query format. The query itself is written in JSON. That's basically saying select users, login, this login name, and then report to me the total count of followers. And the number should be 3. In this case, we don't get 3 because of the authentication. This particular GraphQL API requires authentication. So if I go to the documentation, it should tell me how I should do authentication. Basically, I need to log into my account and get a token. Okay. So what I'm going to do, I'm going to illustrate these concepts. Just bear in mind that you will not be able to do it on your own, because unless if you create your own GitHub account, because it requires authentication. I'm going to sign in to GitHub here. And I'm going to go get, I believe it's in the setting itself. We can go to developer settings and we can get a personal access token. And I'm going to get, if I'm not mistaken, generate a new token, call it test. And I'm going just to select what can the owner of this token do, especially with my own repos. I'm going just to put read user. Let's do this. Let's just do read user profile data. So obviously, if you're doing this for real, you need to put more thought into it, but this is the token I need to use here in my API, and I'm going to paste the token here. All right, so now I do the request, and it's a post request. In this case, I'm posting a query to this resource, and now the response is total count is 3. Now, again, we're not going to use GraphQL in this course. I just want you to be aware of the technology. It's very useful if it's provided. Unfortunately, it's not mainstream, and it's not the only query technology for RESTful APIs. Another technology is called SparkQL, which is provided by many other data vendors, data providers use SparkQL rather than a GraphQL. But it's basically the same idea. It allows us to query resources over the internet, and it has a certain syntax into it. Okay, so that's all for this session. We will follow up with a warm-up and workout exercises.